Hi, my name is Martin. Welcome to Groundhog Graphics. This is chapter 3.1 of Programming in C. In the last chapter, we discussed conditional branching and with the if statement, and we talked about relational operators and how to check variables for equality or inequality and greater than or less than. And in this video, we're going to be discussing how to compound those. We're going to be able to check for multiple conditions using one if statement. Also, as an added note, this is chapter 3.1 and the whole chapter concept, I don't really like it that much. So I'm going to change the video sequence to episodes and just numbers. That way I don't end up with any more floating point chapters. So from now on, the next video will be episode 4 and episode 5, 6, 7, so forth. So let's go ahead and let's begin. Let's create a new project. Console application. C. This will be chapter 3 example. Chapter 3 1 example 1. Next, defaults are fine. Go to our sources. Delete all of this. Include standard input output library. Main, just as we've done before in the previous videos. And I'm going to create two integers. Int a equals 1, comma, and we're making another one, b equals 1. So let's see here. If a equals 1 and two ampersand signs stand for logical and, b equals 1, then we will execute this block of code. Let's see. Condition was true. Condition is true. And then we'll put an else. Put string condition is false. Okay, so now with our if statement, we see we have the relational operator a equals 1, and we also have b equal to 1. But we've combined them with the compound relational operator, also known as a logical operator. We've combined it with logical and. So what the statement is saying is if a is equal to 1 and b is also equal to 1, then the condition is true, and it will print condition is true. If this is false, it will fall back on the else, and it will execute the else block of code that the condition is false. And so let's go ahead and execute and see what our output is. Condition is true. That is right. Both a and b are 1. Okay, so now let's go ahead and make the condition false. Let's make a 0 and let's execute. Yep, condition is now false. Now there is another logical operator, which is called or. And instead of the ampersand signs, it will use two vertical bars. You will find those on the backslash key, and you use shift. It should be underneath your backspace key. Shift backslash two vertical bars, and that is or. So now the statement reads, if A is equal to 1 or B is equal to 1, condition is true. So either one can be true. So let's go ahead and execute. Condition is true. Now let's go up here to B and let's make it a 0. And condition is now false because both A and B are now 0. Neither one equals 1. And let's see here. Now we could also, let me put the and back in here. And let's go up here and let's add another integer, c equals 1. Now we could go and put another and put c equals 1. And we can go ahead and execute this. So you can see you can keep combining relational operators as many as you want. Although it may not be very good practice to combine more than two relational operators in one if, because it'll start to become a little messy. But condition is false. Let's see. C equals 1. Oh, because B. Alright, so let's go up here. Let me fix that. B equals 1. And A equals 1. So now everything's true. Let's execute it. And now condition is true. So you can see we could put A equals 1 and B equals 1 and C equals 1. But that's not really the best way to do this. What we can also do is we can use nested ifs so that we can keep these if statements somewhat human readable. So what we can do is we come down here and we can put another if. So let's say if C equals 1. Then we'll do a puts C equals 1 period semicolon. So now what we have is if A equals 1 and B equals 1, then it will execute the block of code. Inside the block of code we now have if C equals 1. And so let's go ahead and run it. So C equals 1, condition is true, all good. If I want to change C to a 0, then we execute, condition is true, but C does not equal 1, so that's not printed. If we change C to a 1, and we change B to a 0, then we will execute, and we just get condition is false because none of the code inside this block got executed because B did not equal 1. Now another way we could also write this, if we wanted to get rid of the condition is true here, and we can get rid of this little curly brace and this curly brace, and we can bring this up. Now this works with if statements that you don't actually have to have the curly braces if your next line is only one line. So like I could take the if out of here and I could put it in anything I want, but for now I'm going to leave the if. So we could have if here and the next if, and then we could have another if under that, another if. We could just go so on and so on if we wanted to. But for this example, so now it's not going to print. Let me change the print here. So let's see. All is true. Let's put that. All is true. Okay. So now A has to equal 1, B has to equal 1, C has to equal 1 for it to print all is true. So let's go ahead and run that. All is true. There we go. And if we make C a 0 and we execute that, condition is false. Very good. So now, what else can we do here? We saw if a, let's see, we did or. We have, we did nested. So if we have a condition, let's say we use our third logical operator, and this one is not really, it's not really a compound relational operator. It is just a logical operator, and what it does is it turns whatever it sees as false, it turns it true, and if it sees it's true, it turns it false. It flips it the opposite and inverts it. So now I'm going to go ahead and just delete all of this here. And I'm going to put if exclamation point a puts a was actually false, but we inverted it. Semicolon. And we go else. Puts A is true. A is true, but we are in the else block. So now what's going to happen is it's going to go if not A, and it's going to take A, so A right here is a 1. So it'll take A and flip it from being a 1 to a 0, causing it to be false. So then if we'll skip this block of code, it will continue to the else, and it will print A is true, but we are in the else block because the value got inverted. Was inverted. Okay, let's run that. A is true, but we're in the else block because the value was inverted. So now, let me go up here just to prove it, and we will go int A equals 0. And we don't need these anymore. So now, let's go ahead and execute the code. A was actually false, but we inverted it. That's right. A was false. Okay, so now let's try using not, just in a little bit different way. Let's see, A equals 0, and put another parenthesis there. Okay, so now I have isolated A equals 0 and some parentheses. There is operator precedence in C. So the operator exclamation point and the operator for the equality, one of those two will have greater precedence over the other. By isolating the A equality to a 0 in these parentheses, we can make sure that this test is done first. Then when A has either evaluated to true or false, the not will flip that result. So the statement is if A is equal to 0. If that returns a true, the not will flip it to false. If this returns a false, the not will flip it to true. So let's go ahead and execute. And right now in A is 0, so let's see what we have. A is true, but we were in the else block because it was inverted. Let's see here. A is equal to 0, which it was equal to 0. Yes, but we flipped it from true, so that's right. So we flipped it, made it false, made it go into the else block. So if we make A, and remember earlier, I'll show you something after this. Let me show you something. Let's make this one right now, just to prove the point. A was actually false, but we inverted it. Yeah, that's right. Now, of course, we could have written this simpler. We could put, let's see, we could just go, instead of writing it like that, we could just use a relational operator, A, not equal to 0. And we could get the same result. So F9, A is true, but we were in the else block because it was inverted, but this time it was not not inverted because it was not equal to 0. Is that right? If A is not equal to 0. Right. A is not equal to 0, then it will execute here. Well, I guess we had that backwards, but whatever. If it's A is not equal to 0, or if A is not equal to 1, and we execute, then A was actually false, but we inverted it. Okay. So instead of using the not operator like we just did, it would be better to actually use it in this case, like not equal to 1. Well, use the relational operator rather than the logical operator. So now, let's see what we have. Okay, now for another example. Remember earlier I said that the 0 is false, but any other number is true for an if statement. And we can do if A. That's it. Okay. If doesn't care. It just goes, if I get a 0, it's false. If I get anything else, it's true. So let's do if A. And so A equals a negative 1. And let's see. And we'll just put this as A is true. And A is false. Okay. So now int A equals negative 1, and we'll see that it will still be true. So run. A is true. Okay. So instead of a negative 1, let's make it 65535. It just so happens to be the maximum number you can have in an integer that would be 2 bytes. 2 bytes in size, although the integer here is larger. But let's go ahead and execute. A is true. So no matter what A equals, it has to equal 0 to be false. So now we can go and execute. And A is false. So there it is. Alright, so now back to our relational operators. Before we were doing A equals 1 and B equals 1. And we were using these relational operators, and then we're using the AND logical operator. But in actuality, we don't have to use these relational operators at all. We could get rid of the A equals 1 and the B equals, we could just go A and B. Now let's go up here and reinstate B. B equals 1. Alright. So now as a member, now any number besides 0 equates to true in C. So A A being 0 will obviously will make this compare A and B. So this statement reads, if A is true or false, if A and B. So what it is saying is, if A is equal to anything but 0 and B is equal to anything but 0, then it will execute that A is true. But instead we will put A and B are true, and we will put A or B is false. Right, okay. So now we can go ahead and execute this with F9. A or B is false. Well, that would be right because A up here is 0. But let's make A 500 and rerun it. A and B are now true. There we go. So you can see we don't even have to use relational operators with logical operators. They can work just simply comparing two variables to see if they both have a true or a false state within them. So if A and B were both 0, and let's say we came down here and we changed the and, we went with the two vertical bars, which is or. Let's see, A or B is true. A or B, A and B, in this case, and B is false. A and B is false. So now it reads, if A or B. So that means if A or B were anything but 0, then it would execute this block of code. But since they are both 0, it will actually fall into the else. Let's go ahead and execute that. So A and B is false. What will come up? A and B is false. That's right. So now let's go ahead and change A to 1. And let's go ahead and execute that. So A or B is true. That's right, because now A is 1. So, excellent. That's awesome. Okay, well, this concludes our video on compound relational operators, also known as logical operators, and how we can use them to create more complex if statement evaluations of multiple conditions. So I appreciate you watching. Remember that the next episodes are going to be labeled EP or E episode 4, 5, 6, 7, so forth, because I don't want to do any more 3.1s. And I'll catch you next time. Bye.